Okay, the last thing that we have to do is go over the application question. So the first question is the area of a circle can be found using the formula A equals pi times radius squared, where r is the radius of the circle. They want us to find the simplified exponential expression that represents the area below. Now they weren't very clear in showing us that the diameter of the circle, which is the whole way from one side to the other, is that expression 3g to the negative third m squared times 4g m to the negative third. So when we're using the formula for an area of a circle, we don't use the diameter, we use the radius. So just a refresher, the radius is half of the diameter. So what we need to do is take this expression. First we should simplify it, and then we need to divide it by 2. So 3 times 4 gives me 12. G to the negative third times g to the first is g to the negative second. And m to the second times m to the negative third is m to the negative first when we use our exponent rules. This right here represents the diameter. To find the radius, we need to take this expression and divide it by 2. And when we're dividing something by 2, we're just looking at coefficients and dividing those. So 12 divided by 2 is 6. And then g to the negative second, m to the negative first, we can just keep it like that for now. If you really wanted to, you could also write it as 6 over g squared m. And either way, this is your radius. So when you're then using the formula for the area formula is pi times the radius squared. So if you're using this as your radius, 6g to the negative second, m to the negative first, your setup would be like that. If you're using this as your radius, it would be pi times 6 over g squared m to the second power like that. And either way, you would get the same answer. I'm going to use this space over here in number 2 spot to simplify. So this answer over here would be pi times 6 squared is 36. And g to the negative second square, that's going to be g to the negative fourth. And then this would be m to the negative second, which that simplifies to be, I'm just going to move the 36 out front and the pi behind it. 36 pi over g to the fourth, m to the second would be the area of that circle. Using the other expression, we could take this fraction and still use the power of 2, the power rule, and we would get pi times, it would be 36 in the numerator, since 6 squared is 36, and then when we use the power rule in the denominator, g to the fourth, m to the second, and this expression here, pi times that, is the same thing as this, because we can just push the pi up in the numerator next to the 36. So either way, you should get 36 over g to the fourth, m to the second times pi, or 36 pi over g to the fourth, m to the second. So because I need to now do number 2, I'm going to erase this, and I'll just put the final answer here so that you can see the answer is still that 36 pi over g to the fourth, m to the second power. That would be the area of that circle. That was a pretty tough problem. Number 2, also kind of tough. We need to figure out what these 2 question marks are so that the following, this expression right here, simplifies down to this. So we know that this expression has to simplify down to y to the fourth over 8x. So let's look for some similarities. So the first thing I notice, I got 2 to the second over 2 to the I don't know. So that's what we're looking to find. X to the negative second over x to the I don't know, also what we're looking to find. And I have y to the fifth over y to the first, which does actually simplify to be y to the fourth. So that's good. We don't need to figure out anything with the y's. Something that we should realize and note is that 8 is the same thing as 2 to the third power, which will be very helpful in this problem, since what we're trying to do is figure out what the 2 in the denominator exponent is and what the x in the denominator exponent is. Okay, this is kind of like a puzzle. The puzzle is that we are trying to figure out what the question marks are so that they actually equal 2 to the third in the denominator. So right now we have 2 to the second over 2 to the what? Let's start this. And we need it to equal 2 to the third power in the end. So we know that our final answer has to be 2 to the third power in the end, and all the 2's need to be down in the bottom. So in order for us to get this as our final answer, which I can put a 1 here, I have to think about the quotient rule and how I move things from one to the other. In order for me to have 2 to the first power in the numerator right now, but I want to have 2 to the third power in the denominator, think about fractions in the way that they work. 2 to the second power is 2 times 2. And we need to figure out 2 to the what power so that we have 2 to the third power left over in the denominator. Well, in order for us to have 2 to the third power left in the denominator, if these are going to cancel with these, this would actually represent 2 to the third power in the denominator, which means we would need 2 to the fifth power in the denominator. Using the quotient rule, 2 minus 5 represents -3, which is a 2 to the third power in the denominator. So look at this expression, 2 squared over 2 to the fifth. This is 2 to the -3rd, which equals 1 over 2 to the third. So that's what I'm going to need. The first question mark is actually going to be, and I can put my final answer over here, the expression 2 squared x to the -2nd over y to the fifth over, this is definitely going to have to be 2 to the fifth power, since 2 squared over 2 to the fifth, 2 minus 5 is -3, which means we have 2 to the third power, which equals 8 in the denominator. So that's going to be my first answer. For the second part of this, I have x to the -2nd power over x to the something. And I need this to be a single x to the first power in the denominator. So again, think about the way that things cancel out. So if we have x to the -2nd power right now, you can either imagine moving this down below, and this would be x to the second times x to the what actually equals 1 over x to the first. And in order for this to work out, this question mark right here would have to be -1. And the reason why is because if you moved it around, 2 plus -1 gives you that x in the denominator that you need. So if you think about this, if we have x to the -2nd over x to the -1st power, -2 minus -1 is really -2 plus 1, which is -1, and x to the negative power equals 1 over x to the first, which is what we need. So this would be x to the -1st power, and then we have here a plain y. If we took this expression, this is the original expression, and we simplified this, it's going to simplify down to this. 2 to the second over 2 to the fifth, that's going to be 2 to the -3rd. X to the -2nd over x to the -1st, -2 minus -1 is -2 plus 1, which is -1. And then 5 minus 1 is 4. This simplifies to be y to the 4th over 2 to the 3rd, which is 8x, which is the original problem. That was pretty tough, but you guys can definitely do this. Moving on, number 3. We have here the expression below. We have that a is equal to 4. And in that expression, what value of b is needed for the expression to have a value of 81? So we know that when we multiply all this through and simplify it, it equals 81. They tell us that all of the a's are 4. So I'm going to rewrite this and replace 4 in for each one of the a's. Next, I would simplify using the power rule, that 4b to the -4th power. I would get 12 times 4 to the 3rd, b to the 7th, and then times 4 to the -4th, b to the -4th. And simplify what I can. Now, thankfully, all of the numbers, the 12, the 4 to the 3rd, and the 4 to the -4th, this can all be completely done in the calculator. So if you multiply all of it through, you would be able to simplify it all the way down. If you didn't want to do that, you could combine some things together. And when you do like combine it together or just like multiply it through, 768 divided by 4 to the 4th power is what you would get, and that equals 3. So you're going to get 3 when you multiply all that through. And then the b to the 7th times b to the negative 4th, that would be b to the 3rd power. So we have this equation, 3 times b to the power of 3 equals 81. And from here, you can kind of just guess and check, like replace 2 in for b, replace 3 in for b, replace 4 in for b, and solve it out. You also could use what you know about solving equations and try to solve for the variable. So you could divide 81 by 3, and if you did that, you would get what number to the 3rd power equals 27. And we've been dealing with exponents so much recently that you might realize, well, 3 times 3 times 3 is 27. So the answer would actually have to be that b equals 3 in order for this to work. If not, what you could do is just guess and check, like I said. 3 times what number to the 3rd power equals 81? It would be 3, since 3 times 3 times 3 is 27. 3 times 27 is 81, so the answer would be that b is equal to 3. And then the last question we have are those GCF LCM questions that will pop up on the Keystone, so I wanted to pop up on our test. The greatest common factor of these exponential expressions consists of numbers and variables. So the first thing I like to do is separate them into their numbers and their variables. So we have 20, we have x squared, we have y to the 5th for the first one, and for the second one we have 15, x to the 3rd, y to the 6th. For the greatest common factor, you're trying to find the biggest number that goes into the coefficient. So for the factors of 20, we have 1 times 20, 2 times 10, and we have 4 times 5. For 15, 1 times 15, 3 times 5. The greatest common factor of 20 and 15 is definitely 5, so I'm going to circle it. The factors of x squared are x and an x. The factors of x cubed are x times x times x. The greatest number of x's that they share in common, this one has 2, this one has 3, the greatest number they share in common is x squared. It's going to be the smallest of the options. And then for the y's, y to the 5th power is y multiplied by itself 5 times. Y to the 6th power is y multiplied by itself 6 times. The greatest number of y's they share in common are 5y. So altogether, the greatest common factor of all of the numbers and variables would be 5, x squared, y to the 5th. Notice that the exponential expressions we have here, the greatest common factor is actually the smallest number of x's, the smallest number of y's that you have, because they have to be shared in common, and that will always be the smallest of the options. The least common multiple is different. When you're finding the least common multiple of these numbers, still, if it's helpful, split it up. 4x, y to the 4th, 18x squared, y to the 2nd. Finding the least common multiples of the numbers, you literally are going to be adding the numbers to itself until you find a common number, like 4, 8, 12, 16. We're going to keep going, and eventually you'll hit 36. And then 18 is really quick to hit 36, 18 and 36. 36 is definitely going to be the least common multiple of 4 and 18, so I know that that's going to be my like number part of this. But then for the variables, it's kind of confusing. The least common multiple is the smallest multiple of a variable that you can turn all of the other ones into. So x is smaller than x squared. We can turn x into x squared because you can just multiply x times another x and it'll turn into x squared, which means the least common multiple is x squared of the x's. For y to the 4th power, that's y times y times y times y. Y squared is just y times y. The least common multiple is the smallest number of y's that you can turn all of the other ones into. It's going to end up being the largest of the options. So the least common multiple would be 36x squared y to the 4th. If you have any questions about any of these problems, please make sure you're sending me an email or letting me know before our test.